Now in this lesson we look at what's known as permutations. When a given number of objects are arranged and their order is important, the arrangement is called a permutation. Let's look at a few examples. How many different ways can the letters A, B, C and D be arranged if all four letters are used without repetition? Well, let's consider starting firstly with the letter A. We could have A, B, C, D, A, B, D, C. Okay, that's it for A, B. Then we'd move on to A, C, B, D, A, C, D, B, then going to A, D, B, C, and finally A, D, C, B. Okay, that's it for the letter A. Then we would move on to start with the letter B, and we're starting to get these. Now, you've done this since probably very early days in secondary. Okay, that's it for B's, then going on to C's. Alright, so just creating a list there. This is just to illustrate what is going to happen. Finally, starting with D's, we get this list. So, if we count up the number of different arrangements, we come up with 24. So there are 24 ways of doing that. Now, at this level, we want to be doing things a little bit quicker. So, alternatively, let's consider this way. There are four positions. Okay, there's four letters, so let's think of four positions. In that first position, there are four letters to choose from. So there are four ways of filling that first position. Now, once that position is filled, moving on to the next spot, well, there's only three letters left. So there's three ways of doing that. Now, moving on to the next spot, well, we've already placed two letters. So there's only two letters left. And that final spot, well, three letters are placed, so there's only one letter available. So the number of ways then, simply we just multiply the 4 by 3 by 2 by 1. And you may or may not have seen this, but when we multiply a number all the way down to 1, starting with 4, all the way down to 1 in this case, we write as 4 factorial. Alright, 4 exclamation mark, but we call it 4 factorial. And 4 factorial, you'll see it on the calculator, if you haven't already, you will get 24 as the answer there. The next example, how many different ways can the letters from the word great be arranged if all 5 letters are used without repetition? Well, we have 5 letters, so let's consider 5 positions. The first position, the 5 letters can be put in, so there's 5 ways of doing that. The second position, once 1 letter is used, there's only 4 letters left. The next position, we've used up 2 letters, so there's 3 left, and so on. It's going to go down to 2 there, and finally, we just have 1 letter to be chosen. So the number of ways there, we multiply the 5 by the 4 by the 3 by the 2 by the 1, and we do that. Okay, you can do it the long way, or you can use 5 factorial. Either way, we get 120. Next one's a little bit different. How many different ways can the letters from the word great be arranged if only 2 letters are used at a time? So we've only got 2 letters, so there's 2 positions. In the first position though, 5 letters to choose from, so there's 5 ways of choosing that letter. The second position, well, 1 letter is chosen, so we're down to 4, so there's 4 ways of choosing that. So the number of ways simply will be 5 times 4, and that of course is equal to 20. The next example, how many ways can 6 different coloured marbles be arranged in a row? Well, let's do the short way now. The number of ways, we've got 6 different coloured marbles, so it's going to be 6 factorial, which works out to be 720. How many different 7-letter words can be made by rearranging the letters of the word reverse? Well, the word reverse, a little bit different from the ones before, they have some repeated letters in it. So notice there's 2 R's there, and also there are 3 E's. Now that's going to affect the different combinations. The number of different words then, well, there's 7 letters, so let's write our 7 factorial. But we're going to divide, there's 2 R's, so we divide that by 2 factorial. And since there are 3 E's, we also divide by 3 factorial. And we do that on the calculator, we come up with 420. Our final example now, DVDs in a 7-set series labelled Volume 1, Volume 2, Volume 3, all the way up to Volume 7 are placed on a shelf. Part A, how many ways can the 7 DVDs be arranged? Part B, and part C, a couple of different questions on that. Let's look at the solution firstly to part A. Now, we have 7 volumes, so simply the number of ways is going to be 7 factorial, and that works out to be 5040. Let's look at part B now. How many ways can they be arranged if the odd numbers alternate with the even numbers? Well, let's have a look at a little bit of a diagram to help us out here. There are 7 positions. Let's just mark them down. 7 there. Now, it's got to go odd, even, odd, even, odd, even, and then odd. Okay, there was one more odd, so the odds have to be on the outside there. Now, let's just consider the odds for a moment. They are 1, 3, 5, and 7, and we know now that that can be arranged 4 factorial ways. The even numbers, which are 2, 4, and 6, amongst themselves, there are 3 of them, so they can be arranged 3 factorial ways. And then 4 factorial ways by 3 factorial ways, therefore the total number of ways, we multiply those, and we end up getting 144. Part C, how many ways can they be arranged if all the odd numbers are next to each other? Right, again, a little diagram will help out. We might have all the odds together, and then the 3 evens. Or we could have an even, then the 4 odds, then the 2 evens. 2 evens at the start, the odds together, and then the last even. Or finally 3 evens, and then the odds together like that. Now let's consider each way. That first scenario, well, those odds, there's 4 of them, they can be arranged 4 factorial ways, and the evens can be mixed up amongst themselves 3 factorial ways, so we multiply. The next scenario, again, the odds, 4 factorial ways, and those 3 evens can be jumbled up 3 factorial ways. The next scenario looks fairly similar. You've got your 4 factorial for the odds, and then the evens again, 3 factorial. And final scenario there, the odds again 4 factorial, and the evens again jumbled up 3 factorial ways. So all together, it's a matter of adding those up, or the quickest way, with total number of ways, is going to be 4 times the 4 factorial times 3 factorial, and that works out to be 576 ways. Excellent. Well, that concludes the lesson. Good luck with your questions.